All right, so today we're going to start off chapter 11, which has to do all with solving proportions. And so the first thing I'd like you to do today is write down, well, let's just choose a couple. Let's write down this one for a little warm up, and this one, and let's see if you guys remember how to either find a pattern, see if you can simplify fractions, and if you can't find a pattern, cross multiply. Now if we take a look at number 1, once again it might be a great idea to write down these things. Is there a pattern? We're trying to solve for b. Is there a pattern from 9 to 30? No, there's not. But we can simplify this fraction, which goes to 1/3. And then we're going to have b over 30. And then if you remember, oh, what's the pattern? We multiply by 10. So we have to multiply by 10 here. So therefore 1 times 10, b equals 10. In number 4, once again, we do have a fraction that can be reduced. If you notice, we can divide both the top and the bottom by 2. But if you see, there is a pattern. 28 times 2 equals 56. So that means 26 times 2 would equal m. Well, 26 times 2, last time I looked, 52. Now, we didn't use cross multiplication because we didn't have to on these, but we will get into that because today is all about solving proportions. Now the first thing I want to explain is that proportions, this word that we've used since, 7th, 8th, 6th grade, is when you have a fraction equal to a fraction. So you can have anything from 1/2 is equal to 2/4. That's an example of a proportion. You could have x over 10 equals, say we have 10 over 15. And then when your book asks you, what are the extremes? All right, the extremes are these guys, extremes. And the means are these two. Now, just to let you know what the reciprocal property is, if we would use this original, reciprocal property would just say that 10 over x equals 15 over 10. So it just flips both of them. And that's what we call the reciprocal property. The cross product property just says x over 10 equals 10 over 15. Cross product property just says that we can multiply cross products. So we would get 10 times 10 has to equal 15 times x. Once again, cross product, that allows us to cross multiply. And notice that we're multiplying the means, if we use this word, the means by the extremes, and we set it equal to each other. So in this first one, we have 1, 2, 3, 4 questions. I would like you to tell me yes or no if this is correct. Tell me if this is correct from our original. Is this correct and this correct? And at this time, I would like you to pause the video, get this down, and answer those questions. And now that you're back, A and B and D and C would not be correct because that is not cross multiplying. That's just multiplying the top and the bottom. We can't do that. Right here, if you notice, what switched? Well, A and B stayed the same, C and D switched. And no, once again, you would have to switch both of them. If we look at this one, A over D and B over C, what switched was, well, let's see here. This used to be B. Oh, this is really crazy, isn't it? This is a no too, because there used to be a B here, there used to be a C here, and there used to be a D here. And so we just kind of switch those around, and you can't do that either. But right here would be an example of what is okay. Yes, it's okay because they just use the property that flips it. Now, if we keep going, it says solve the proportion. We can solve this just like we started class. But if you notice, there's not a nice relationship. So we would want to cross multiply. And we get 2 times W equals 3 times 3. Now, to get W all by itself, we should probably simplify. So we're going to get 2W equals 9. Now, the opposite of multiplication is division. So we divide both sides by 2. Getting W equals 4.5. Now, this cross multiplying should be familiar. You learned it in 7th grade. Why do I know that? Because I teach it. But here is where we're going to use our knowledge about cross multiplying. So please write down the original, you guys, in your notes. Let's go through this. Once again, we have to cross multiply. We would get 50 equals, please make sure there's an equal sign, and then 2t times t is going to be 2t squared. Now, before we say t equals something, we got to divide both sides by 2, meaning that we're going to get t squared equals 25, because 50 divided by 2 is 25. Now, the opposite of squaring something is going to be taking the square root. And this little 2 has to remind us that how many answers are we going to have? 2. Yeah, we're going to have 2 answers. One's going to be positive, one's going to be negative. Square root of 25 is 5. Now, one thing I'd like you to write in your notebooks is, hey, you always have to check your work. And if the solution doesn't work, it's called extraneous. And I hope you guys can say that out loud. Extraneous, okay? That means it doesn't work. Well, what does that mean? Well, right here. If we plug in 4.5, that's okay. That's okay. It doesn't make our denominator undefined. Right here, that's okay if we plug in 5 or negative 5. That's all right. But we better just check just to be sure. So let's check negative 5. So we'll go 10 divided by negative 5 equals 2 times negative 5 over 5. Well, this will simplify to negative 2. And this will also simplify to negative 2. Now, if these were both positive, this would simplify to 2. And this would simplify to 2 as well. So both of those answers check out. Now, if we keep going, this is where it gets interesting. Because, once again, we want to cross multiply. But anytime you have a binomial, we want to put parentheses around that. Because then we're going to have d times that. And then we're going to get negative 3 times 2d. Now, if I'm going too fast, please feel free to pause and tell the teacher, and we can go through it. Right here, we have to distribute. We have d squared minus 3d when we distribute d times negative 3. And then we get negative 3 times 2d, which is negative 6d. Well, if you notice, it's asking us to solve. This is just like last chapter. So we're going to want to get everything to one side. And the opposite of a negative 6d is to add 6d to both sides. Leaving us with, I'm going to change colors real quick, d squared plus 3d equals 0. Now, to be able to solve, this is where we want to factor. So yes, last chapter is still in play. So we could factor out a d. And we're going to put that d in front, and we'll be left with d plus 3. Now, if you remember how to solve, we would set this equal to 0, so that's easy for our first one. And we set this equal to 0, which means that our answer would be negative 3. We'll check our answers right after you do number 8. Well, essentially, we can just do it right now. Anytime your denominator would be 0, you can't divide by 0. So make sure that you would cross that out because it's extraneous. Because once again, you can't divide by 0. Now, it can be 0 up top, that doesn't matter, okay? But you just can't divide by 0. Now, moving on, there's not a nice relationship. So once again, we have to cross multiply today. 4 times x is going to be 4x. Equals, please make sure you put an equal sign in there. Then we're going to get 5 times the quantity of x plus 3. And when we do that, we have to distribute. And we'll have 5x then plus 15.
I'm not an idiot.
Now, I'm recording. Thank you. And so then, what makes this one different than this one is it just has a single variable. You've solved stuff like this since 8th grade. So we just want to get our variables to one side. And since this is already almost by itself, I would say you would want to get rid of the 5x. And to get rid of the 5x, we would want to subtract. And so we're going to get 4x minus 5x, which would be negative x. 5x minus 5x would go to 0, leaving us with 15. Now, beware. You don't want to say that negative x equals 15. You want to solve for x. So once again, you just divide both sides by negative 1. We've done this before. And you get negative 15. Now, once again, you always want to check to see if your answers are extraneous. To make a long story short, you just want to make sure that your denominator can never equal 0. Because if it does, that means it's undefined. And so, right here, your denominator, there's no variable in there, so you're okay. Then, once again, if you don't have this done, it's okay. Like, just ask for them to pause so you can get set up. But I'd like you to write this proportion down. Now, this one's going to take a little time, and you'll find out why. First thing I want you to remember, okay, to solve proportions, we almost always cross multiply. Okay, and maybe we should go like this. And so when we cross multiply, if it's a binomial, please put parentheses around it. So let's check this out. We can't cross cancel like this because there's a plus or a minus sign, so please be aware that you can't just cross out the x's. You can't do that when there's a plus or minus sign. And so if we cross multiply, like I've already stated, we would have negative 5 times the quantity of x plus 3. And then we would get the quantity of x plus 5 times the quantity of x minus 3. Now from here, we would want to simplify. And to simplify, that means multiply. And so, once again, it looks like last chapter. Over here, we would have to FOIL. So please pause right now, and I would like you to simplify. So let's check it out. Negative 5x plus negative 15, because that's going to be negative 5 times 3, equals x times x is going to be x squared. X times negative 3 is going to be minus 3x. Right here, it's going to be plus 5x. And a positive times a negative is going to be a minus 15. After this step, once you see an x squared, you should know to bring everything to this side. But first, I would like to simplify this. I'll just use another color. And so we'll have x squared. A negative 3x plus 5x is positive 2x minus 15. And right here, to bring these two to the other side, we're going to add 5x, because then that crosses out. And so we're going to add 5x to both sides of our equal sign. The opposite of a negative 15 is to add 15 to both sides. And if you notice, there won't be anything left over here. We will have 0, and maybe I should stay organized. 0 equals, well, we're going to have x squared plus 7x. And this kind of looks similar to one of the other ones. Well, to be able to solve, we have to factor. Maybe you want to write that down to remind yourselves. Okay? Factor. Yes, I know that word is last chapter, but that's the cool thing about math. We got to keep adding to it. So we can divide both of these by x. And when we factor out an x, we're going to be left with x plus 7 equals 0. And once again, We set our factors equal to 0. So our first answer is 0. Our next answer, we set it equal to 0, would actually be -7. Now, if you remember, we do want to check all of our answers. And would plugging in 0 make our denominator 0? No, this would still be 5. So we're okay. And then plugging in a -7, would that make our denominator 0? No. Okay, that would actually be a 2 or a -2. So that's okay. Both of these are possible solutions. Now let's just do one more. And let's see if I can choose a good one. Here's an all right one. Okay. Here's an all right one. Do I go patriotic or do I go patriotic? Let's go with this one. So right now I'd like you to pause, I'd like you to read, and I'd like you to try to set it up. And by set it up, I mean set up a proportion. So en route, Ellendale's 4th of July parade stretches, and thank you guys for being patient. It'll just take me one more minute. Stretches 2 miles. Spectators are usually evenly distributed along both sides of the route. I know a lot of you guys are like, this isn't right. I know, it's just a math problem. I tried to make it fit. Now, on one side of a 50-foot section, you counted 15 kids. Estimate the number of children who attended the parade. Okay, so the first thing we're given is feet. So maybe we just want to go feet and feet. And the other thing we're given is kids. So maybe we want to go kids and kids. Now when we set up a proportion, usually we are trying to find one missing piece. And so let's check it out. We're first given that the whole parade is this many feet long. I know, that's expanding Ellendale's parade just a little bit. And then over here, we found out that over 50 feet, there are 15 kids. And so tonight, when you read problems like this, I would like you to label the two things that you find, because that just helps us stay organized. Now, we don't know how many kids are total, but this is what I want to challenge you with. How many sides do we have of a parade? Well, there's going to be fans on both sides, right? And so we need to remember then, oh, well, if it's 2 miles, okay, there's actually 2 sides. So on one side of a 50-foot, there's 15 kids. So we should actually make 50 feet on both sides, okay? 50 feet on both sides would be 30 kids. So you might want to do that, because then it would tell us how many total. We don't have to do anything. Now watch this. We could cross multiply as before, but anytime you have a fraction you can reduce, I would reduce it. So you're going to have this, 10,560, if we cross multiply, times 3 equals 5 times x. X is just standing for the number of kids total. We divide both sides by 5. Okay? And then look at this. How many times does 5 go into here? Well, this is where we can just set up a little side problem. 2, 1, 1, remainder 1. Okay, it would be that. And then we just have to multiply this number by 3. $6,336. What does that represent? Kids, or total kids at the parade. Now, if you didn't multiply this by 2 right away, then you could just multiply the answer, okay, that you got by 2 to represent both sides. So please, please, please don't check out on these word problems, because today you don't even have that many, all right? But we have 11.11. We're in our books today, page 646, and 8 through 40 even. Thanks, and you get the rest of the time to work.